All right, welcome to our Teaching with Scratch webinar. We're glad that you joined us. So in this presentation, I'm going to try to give you more than just information about using Scratch. I'm going to try to give you some of my own experiences and my tips about what I do and what I've tried and whether it worked or it didn't work. So hopefully you'll leave feeling better about using Scratch in your classroom with maybe some hints and tips that can help you really make effective use of Scratch and a Scratch teacher account. So let's start out with just what is Scratch. Well, Scratch is a drag and drop programming environment. It's blocks based rather than text based. And that simply means that instead of needing to learn a lot of keywords and grammar and syntax, you simply use puzzle pieces that you can drag around and connect and assemble to form sequences of instructions. And to me, this really helps reduce the cognitive overload that is often associated with trying to learn how to be a programmer. Because when you have never programmed before, you're really trying to learn two different things. You're learning how to organize your thoughts into a logical algorithm to perform some task, but then you're also learning a foreign language at the same time, and you're having to learn grammar and syntax and keywords and punctuation, and the punctuation can be really obscure at times. So let's take a look at the Scratch development environment. So I'm signed into the Scratch online environment. There are environments that you can download for Mac or Linux or Windows. You get the same user experience no matter if you're using it online or if you're using it locally. The only real difference is that with local installations, you can save and load your files to your own computer. Now, with the online environment, you can download your projects and upload your projects to move them back and forth. But what you're actually working on in the online environment is in a hosted sort of cloud-based configuration. All right, so I've gone into Scratch. This is a new Scratch project. I just kind of want to give you the lay of the land. So over here on the left, we have color-coded categories, all right? And so everything here that is light blue is related in some way to motion. And it's going to allow us to move or turn or reposition the character we have on the screen over here on the right. And I'll talk about those in just a minute. But we have categories for motion. We have categories for looks. These are the way that that character is going to appear. We have a category for sound. There's lots of different sound effects that we can add. We can even play musical notes. We have a category called events, and that allows our program to interact with the user in some way. There are lots of different events that we can respond to. We have a section called control, and this is where you start to get into some things that are real computer science elements. We have loops. We have a repeat a certain number of times loop. We have a forever loop, and we have a repeat until a condition is true loop. We also have what are called conditional statements. This is if then. So if this condition that I slap into that hexagon there is true, then I would perform the instruction that goes in the slot. And then I have one that allows me to also have an otherwise slot. So if the condition is true, I do what's in the top slot, but if it's not true, I do what's in the bottom slot. I have a category for sensing. This allows me to get information from the world, usually the virtual world that my little character is living in over here on the right. I have an operators category, and these are my mathematical operators, plus, minus, times, divided by, a random number generator, some comparisons, greater than, less than, equal to, some Boolean conditions, and, or, and not, and then some other things for working with text, for doing various kinds of more advanced mathematics. So, you know, we've got a square root operator, we've got some trig functions, we've got a logarithmic function, and so on. So Scratch, although it's kind of graphical and looks sort of kidsy, it can be used for doing much more sophisticated types of programming. We have a category for variables. Again, this is sort of a computer science thing. in computing and programming, we use variables to maintain the internal state of a program. And so here I have different ways that I can manipulate variables. I also have a place I can manipulate lists. Those are sequences of variable values. And then finally, I have something here called blocks. And in other programming languages, blocks are usually called functions or procedures, or maybe methods. Now, those words all have sort of subtle meanings, differences of meaning in other programming languages, but in Scratch, they're called my blocks. Now, the area here with the instructions in it, I refer to that as the instructions bin. It's kind of like your jigsaw puzzle pieces box. This is where all of your instructions are. And to write programs, you simply drag the instruction from the bin into this code editor or code window, and then you can snap them together. All right, so this would tell my character over here on the right to move 10 steps in whatever direction he is facing and then turn 15 degrees. And if I click on that, we can see that the cat has obliged me and has done what I told him to do. So that's all it is. All I have to do is assemble these instructions to form sequences, and then the computer will perform those sequences. Now, the area over here to the right is called the stage. That's where all the action takes place. The things I can put on the stage are called sprites, and the default sprite for a Scratch program is our friend here, the cat. But there are many other sprites that I can pick from, all sorts of characters that I can pull in to make part of my program or use to tell a story or whatever it is I want to do. I also have a way that I can, I can actually create my own sprite characters as well. There is an editor. So I can go here and use drawing tools and design my own sprites that I can then put on the stage. And then I also have an ability, sorry, I keep clicking that. I also have an ability to upload a sprite from a source that I might have downloaded from the internet. So I can go to the internet, find a picture that I like, I can upload it from that picture, and then that brings it into my program. I can use it as a backdrop or as a character. The backdrop is the background of my stage. And again, it starts out just plain white, but like the sprites, there are lots to pick from. So I can set my program in some kind of a world or a scene. And I also can edit my own backdrop with a editor tool that's very similar to what I would use for my sprites. And then again, I have a way to upload a new backdrop from it, an image that I may have taken with my own camera or downloaded from the internet or whatever. One more comment about the sprites is that many sprites have multiple costumes. A costume is just a different appearance, and this allows us to do some simple animation. All right, just like flip card animation, where you have a series of images and you flip through them very quickly. We can tell our sprite to change its costume very quickly in a loop, and that will make it look like it's actually animated. All right, so that's just kind of a general overview of the Scratch development environment. So let's talk now about a Scratch teacher account. Okay, so I'm going to go back to the My Stuff area where all of my projects are. I'm going to sign out of my Scratch account, because when you sign up for a teacher account, you don't click the Join Scratch button here. You actually want to scroll down and find the For Educators button here. If you go to the For Educators button, there's a lot of information about using Scratch in the classroom and the support and resources that are available to you. And then down here about halfway, you'll find the teacher accounts in Scratch, and you can request an account. All right, now the accounts are free, but they do have to be requested. They go through some sort of internal verification process by those who maintain Scratch. And ultimately, you'll more than likely get approved for your Scratch teacher account. Now, a tip from me is that I actually have multiple Scratch accounts. All right, so if I click on the sign in button here, and then I click this little icon in my Chrome toolbar, This is a password manager called Bitwarden. I don't have any affiliation with Bitwarden other than I'm a user and I really like it. But you'll see here that I have lots of different Scratch accounts, okay? And these allow me to do, I use them in different ways, right? So I have my personal Scratch account. That's where I do a lot of my research and development. I experiment there. I have accounts for the different classes that I teach so that I can actually pretend in those classes to be a student, and I can work alongside the students and kind of demonstrate as we go. And then I have my Scratch teacher account, and I'm going to show that one to you in just a minute. I do recommend that you have some kind of a password manager to keep up with all of those accounts because it can get very confusing to remember what account you're signed into. It's also a bit of a challenge because when you have multiple accounts, not only in Scratch, but other tools I use like Tinkercad or Replit, if I need to be two different people at the same time, in other words, if I need to be signed into that tool as two different accounts, say the student account and the teacher account at the same time, I have to use two browsers, okay, because it uses the cookies in a given browser to remember who I am. So if I sign into Scratch in Chrome as a student, then I use Firefox to sign into my teacher account at the same time. All right, so this is my Scratch teacher account. And over here on my user menu, I have a place to manage my classes. So if I click on that, we can see lots of classes that I have set up. These are classes that I've either taught in the past or that I'm teaching right now. And I've created one for this webinar, TWS Teaching with Scratch -1122, the month and the year that I'm giving the webinar. I do often code my my teacher account classes because Scratch doesn't want you to use anything that is identifiable. So they wouldn't want me to put the school name in my class accounts, and the same with the student account. So I use this coded system where I just use an abbreviated prefix and a term so that I can, if I'm teaching at that school again, next year I can reuse the prefix and just give it a new term number. Now, once I go into my my class, I have the students menu here. So we're going to go into the students menu. You can see I've already set up several different student accounts. And these are what the students would use. Now, there's lots of different ways to create a student account. You can create them one at a time with this new student button. I'm actually going to walk through that in a minute. You can also upload a CSV file, a list of your students and their the names and the nicknames that you want to give them. Or you can simply let the students create their own accounts. You can generate a sign-up link, send that to them. That allows them to create their own username and password, but it associates that new account for them with your class. Okay, now I actually prefer to create the student accounts up front with the new student option so that I can maintain some consistency on the usernames. All right, so instead of having randomly generated or what seem like randomly generated student names because they created them themselves, I have an organized set of student accounts that belong in this class. And I usually start with the class name first, so TWS-1122. And then I generally start with 100. So it's dash, a 3-digit number starting at 100. Now for this class, I created an 099 so that I could experiment with a little bit just before I set up the rest. I also often reserve the 100 account for myself. Okay, so that is my student account for this class. And then the first student on my roster would be given 101, the second would be 102, and so on. So let me go ahead and add a 15th student to this class. It's very simple. I just go to New Student. It's going to give me the class that I'm currently looking at, but if that's not the right one, I can pick one of the other classes that I have created. I can create whatever username I want. Again, I generally stick with the class name as the prefix, and then I put a dash and a 3-digit number that started with 100. So I'm up to 115 for this class. Now, again, the people who maintain Scratch, which is the Massachusetts Institute of Technology, it's a group called the Lifelong Kindergartner Group. They do not want you to do anything that would associate the account with an individual, nothing identifiable. And so this conforms to that guideline as well. I'm going to add the student, and we'll see that now my 15th student has shown up in my class. Now, when you create the accounts in this way, if you create the accounts up front, the password, the default password for the student accounts is the same as your teacher account username. So if you look up here in the upper right, my teacher account username is Excalibur STEM with a capital E and a capital S. So for all of these accounts, the password has been set to Excalibur STEM. Now, the first time the students log into these accounts, it will prompt them to change their password, and they can set it to whatever they want. I know it's not good practice to get in the habit of writing down usernames and passwords, but I work often with middle school students, and so I do sometimes encourage them to write down their username and their password. Invariably, somebody's going to forget, but it's very easy if that happens. You can go to account settings, and you have two options. One is to tell the student to enter a new password for themselves the next time they sign in. And so basically you're just resetting the account back to its initial state where it knows it needs to get a new password from the student, or you can simply assign the student a new password. All right, I usually do the first and prompt the student, let them set their own password. But if it becomes a kind of a habitual problem, I will often manually change it so that I can just tell them it's this. This is your password. All right, so I did mention that I like to retain one of these accounts for my own use, and I usually create the one ending in 100. That is mine. Now, the next thing I want to mention about class accounts is that you have something called a studio. Okay, now, if you've used other learning management systems, you might have what's called an assignment Dropbox. Studio is sort of the Scratch teacher account version of an assignment Dropbox. Okay, so it's a place that you are setting up where students can contribute a particular project, and that groups them together so that you then can go and give the students a grade. You can do their assessments there. So I'm going to create a class studio for our class. I'm going to call it FizzBuzz because that's the name of the project that I would want the students to submit to this studio. And I have a chance to give the studio a description. I generally don't because I'm working with these students on an almost daily basis. So we know what we're doing. It really doesn't matter if I put a description in there or I don't. So I often will leave the description blank, but I will give it the same name as the project we're working on. Now, again, another tip, I have had trouble with some of the names that I tend to give to my projects. I don't know what kind of the unwritten rules for the studio names are, but it seems that it does not like certain punctuation, and it also may not like names that exceed some character limit. It creates a little bit of a nuisance problem. You can add the studio and it may say, oh, there was an error adding that studio, but then when you go and look in your studios list, it looks like it's there. If that happens to you and you create a studio and it gives you an error, but then it still shows up, I would delete the studio and recreate it. Because my experience is that when you get an error trying to create it, it hasn't actually been created, even if you see it in your list. The other thing I want to mention about studios is that unlike kind of the traditional paper and pencil way of turning in assignments, there's no sense of finality associated with turning in a project to a studio. Okay, so once a student shares their project and adds it to the studio, it's just making it visible to you as the teacher of the class, but they can continue to make changes to it. All right, and their changes will be reflected in the version that you see. So it's not like making a copy of it and giving you the copy. It's making it visible to you in whatever form is most current in the student's account. So it's really just a little bit more than in Scratch, you can share projects and then anyone in the world can see the project that you created. And that is a part of adding it to the studio. But by adding it to a studio, you are putting it in a place that makes it easy to find. Okay, and that's, I guess, the real advantage of the studio over just sharing and have the students sending you the link to their shared project. The idea that it's not final could be a good thing, or it could be a bad thing. Okay, if you're trying to enforce like a deadline on the project, that's hard to do with a studio because they can continue to work on it until the point where you actually look at it and grade it. Now they could continue working on it, but you will have already graded it and any changes they make might not be reflected in their grade. But on the positive side, the fact that it continues to be kind of a live working project is that you can use it to sort of check in on them. You can have them share their project the very first day when they begin working on it, when there's actually no code in it. And then as they continue to work on that project, you can dip in and sort of take a look at how they're doing, give them suggestions and so on. One last note about projects that go into the studio is that you as the teacher can actually make changes in the project, but those changes don't stick. Now, what I mean by that is I go into a project and I find that the student has made a mistake somewhere in the code that actually prevents it from running and would prevent me from grading it any further. I wouldn't be able to assess it farther than the error. But I can make a change, fix that little error temporarily so that I can see the rest of what the program would do if that part had been correct. And maybe I can give the student some credit for that extra work. That change I make won't stick in the student's project. And that's, to me, a good thing. That lets me go in and do some things that help me to give the student a better, maybe a more fair grade on their project. But the student won't see those changes. All right, now I can give them the same feedback in another form, but it won't actually change their project. So let's now go and look at what it is like for the student to sign into this account. So I'm in Firefox, my teacher account now. I'm going to put a different hat on. I'm going to go back to Chrome and I'm going to be a student now. So I'm going to sign in and I know that my class account that was assigned to me is TWS-1122- and I was assigned student 100. Okay, so that's me. My default password is Excalibur STEM with a capital E and a capital S. All right, and so the first time the student signs in, it says, hey, you've been invited to join this class. Okay, so I'm going to say get started. It's prompting me to give myself a new password. So I will go ahead and do that. It is asking for some personal information. Now, there is a note up here that says this information is not stored anywhere at Scratch. They use this just for demographic research. You can tell students to put in the correct information. They can put in their incorrect information. It's kind of up to you and the school and the policies and so on. But again, this information is not stored at Scratch. They don't use it for anything other than anonymous research. All right, so once I've entered that information, I can go to the class and now I have my own new Scratch dashboard, okay? And I'm signed in as a student in that class. If I go over here to the folder, that is my stuff. That's like my documents on my computer. That's where all my projects are gonna show up. And that's where I would go to create a new project. All right. So let's now look at some of the ways that I use to scaffold projects for students. All right, we've looked kind of at the back end. Now let's look at the sort of the meat of how an actual class might operate. So let's start with what I call the FizzBuzz project. Now, FizzBuzz is a sort of a computer science problem. It's a fairly common, it's not very difficult. And I created what I call a starter project. Okay, so back in Firefox in my teacher account, teachers also have a My Stuff. And so I have created this FizzBuzz challenge project. And what I have done here, you can see I've given it some instructions so that the students can see this. I've also put inside a comment block that lets me also outline the instructions for this particular challenge. But then I've given the students all the pieces that they need to complete this program, but they're not connected to each other. Okay, so this is kind of like getting a Lego set that can build one thing, or a model car or a model airplane. You get all the pieces you need to put that together. That's exactly what I've done here. I'm giving them all the pieces that they need, but I haven't put them in order. Now, I have actually given them all of the right values for all of the ovals as well. Okay, so that says fizz, that says buzz, and that says FizzBuzz. I didn't make the students put their own text in those bubbles. I didn't make them put their own values in any of the numeric bubbles. Okay, I've already done all that work for them. This would be a project that I would give to students fairly early after first starting to use Scratch, because they need more help. They need more support at this point. And so all I'm asking them to do is to assemble all of these pieces into a program that satisfies these requirements. In FizzBuzz, the program counts from 1 to 50, saying each number as it goes. However, if the number is a multiple of 3, the program says fizz instead of the number. If the number is a multiple of 5, the program says buzz instead of the number. And if the number is a multiple of both 3 and 5, the program says FizzBuzz instead of the number. And then I give an example of what it should do. And I've told them to reassemble these instructions. Okay, so what I can do now is go back to the project page. I can share this project. And then down here in the lower right, I have a copy link button. Okay, so I can copy the link. I can email that to my students. The students then would click the link. So I'm just going to pop it into my location bar back in Chrome, where I am a student. And again, it remembered that I was the student because it put a cookie on my computer. And now I have the FizzBuzz challenge. Okay, so I'm now ready to start this assessment. All right, and I would probably use this like a little mini or simple assessment. What I want to do next is remix it. Okay, because right now I'm looking at the teacher's version of this FizzBuzz challenge. What Remix does in Scratch is create a copy in your own workspace that you can then edit independently of wherever you got it from. Okay, so I'm going to remix the project. Now I have gone into the project. It has named it FizzBuzz Challenge Remix. If I go back out to the My Stuff folder, I now see the FizzBuzz Challenge Remix project. But this now is my copy of it. And every student will end up having their own copy, and they can do the work for themselves. Okay, so if I go to see inside again, that will open the project back up. I have a copy of the instructions. I also can go back to the project page and I can see the instructions here. Okay, but now I'm actually ready to work. All right, so the first thing that we want to do here is start with a counter that begins at 1. Now I'm going to take an if, and if that counter is a multiple of 15. Okay, now this instruction here that I just pulled over is called the mod or the modulo operator. And modulo in math is the remainder of a division problem. So if I can take the counter and divide it by 15 and get a remainder of 0, then I know that counter is a multiple of 15. Okay, now if that is the case, I need to say fizz buzz, because according to my rule, if it's a multiple of 15, I should say fizz buzz. I do have to check to see if it's a multiple of 15 before I check to see if it's a multiple of 3 or 5, because if it's a multiple of 15, it will also be a multiple of 3 and a multiple of 5. All right, so if it is not a multiple of 15, I want to check to see if dividing it by 5 gives me a remainder of 0. Because if that's true, then it is a multiple of 5, in which case I should say buzz. And then lastly, I can check to see if it is a multiple of 3. So I'm going to check to see if dividing by 3 gives me a remainder of 0. If so, I'm going to say fizz. And if it is not a multiple of 15, 5, or 3, I want to simply say the number. All right, now I've got a couple of extra pieces here, and I realize that I need to do this for every number between 1 and 50. Okay, so I need to take this repeat until, and I need to put that entire if block inside of it. And that's an advantage, again, for students who are just learning. They would recognize that, I got some extra pieces. I must not have done something right. Let me take a look at what I have remaining and see what adjustments I can make. Okay, so if I start the counter at 1, I do this inside the loop until the counter is greater than 50. That means that before I loop back up for that check, I need to increase the counter by 1. And then I just need to wait so that I actually see the count take place. Okay, so start with a counter at 1, repeat until counter is greater than 50. If I start at 1, 1 is clearly not greater than 50, so we'll go inside, we'll see if it's a multiple of 15, 5, or 3. If not, we'll say the number itself. And then regardless of what decision we made about what to say, we increment our counter, wait half a second. This little arrow tells me go back up to the repeat until. Now counter is 2. 2 is still not greater than 50. And we will watch it go through that again. All right, if I click the green flag, that's how I run a program in Scratch. And just kind of as an aside, the when green flag clicked is what's called an event handler. Clicking the green flag generates an event that causes me to begin executing this sequence of instructions. Now I can watch the cat. He got to 3, said fizz. He got to 5, said buzz. Got to 6, said fizz. Got to 15, he's now going to say fizz buzz. And he's going to continue going all the way to 50. Everything that's a multiple of 3 says fizz. Everything a multiple of 5 says buzz. Everything that's a multiple of 15 says fizz buzz. And if it's not any of those things, it says the number. So I'm the student. I'm finished with the project. I'm ready to turn it in. So I need to go back to my project page. I have to share it first. Okay, there is no way around the fact that to put a project in a studio, it has to be shared. Sharing does make it public to the world. Anybody can now see that project if they want to go and hunt it down. Down here, though, I have an Add to Studio button. So I'm going to click that. It's going to go and find all of the studios that belong to the class that I also belong to, and it's going to list them here. I simply need to find the one that I want to put the project into, and then say OK. All right, so now switching hats again, I'm going to go back to Firefox. I am again the teacher, so I'm going to go to My Classes. I'm going to go down to this class, the Teaching with Scratch 1122 class. I'm going to go to the Studios menu item here, link. And there is my FizzBuzz Studio, and I can see there is one submission. So if I click on that, the submission is from student 100 in this class. That's me. And if I click on it, I can see inside that is the student's work. All right. And now I could give this project a grade. All right. So let's now talk about how do I go about grading a project like this? Well, for FizzBuzz, I created a Google Sheet. And you can see down here on the lower left, I have all of my students with their Scratch usernames for this class. And then I have the requirements. Now, this is a sort of a simple rubric, and this one is an absent present kind of rubric. The element is either there and can be identified in the project, or it is missing. All right, now, if it is there, they get a point. If it is missing, they get no points. This one gets 2 points, says FizzBuzz, if it's a multiple of 15. The reason that gets 2 points is because if I go look at the code, not only do I have to associate counter mod 15 equals 0 with FizzBuzz, that would be 1 point, but I also have to recognize that that if condition must come first. Because if I put either of these other if conditions first, and I determined that the number was in fact a multiple of 5, I would say buzz, but I would never get the chance to check to see if it's a multiple of 15. If I put the if statement outside and did both multiple of 15 and multiple of 5, then it would say both FizzBuzz and buzz for the same number, and that wouldn't be correct either. Okay, so for that particular element, it needed to be associated with being a multiple of 15, and it had to come first. That's why it got 2 points instead of 1. All right, but this is a nice, easy way to grade these projects. I use 2 monitors on my computer, so I can take the score sheet, put it over on the left monitor, put the project up on the right monitor, and simply walk through the criteria, compare it against the project, give them a point. I might also give them partial credit. I do that a lot. So here, this particular student got 3/4 of a point because maybe they incremented the counter inside the loop, but maybe instead of it being at the bottom, it was somewhere else, like at the top or inside one of these if conditions. So technically it's still inside the loop, but it's not in the right place and the result won't be correct. So I might give them partial credit for that. Again, based on where they are developmentally as a programmer. A beginning programmer, I would be far more lenient than someone who has more experience and probably should know where that increment has to go. Now, often when I put a partial credit, I will also then create a comment to go with it. So in Google Sheets, you have a hotkey, or you can simply say insert comment. I might say counter is incremented in the loop, but at the beginning, not the end. All right, and I do that so that I remember why I gave the student partial credit for that. If the parent ever asks, or if the student ever asks, why did they get 3/4 of a point? I can tell them specifically why they lost that 1/4 point. Okay, so that's one kind of a rubric that I might use. Now, I've done other kinds of rubrics. I'm going to show you one here called Add Agency. This is a project that had a little bit more of a creative element to it. The students had to write their own commercial. They had to come up with characters, sprites, and a backdrop, and they had to create dialogue, and their characters had to interact with one another in some way. So because it was a bit more open-ended, there was a way to say that the criteria may have gone well above what I expected them to do. It may have met what I expected them to do. It may have been just below what I expected them to do, maybe part of what they should have been able to do, but not entirely, or that it was not there at all. Okay, so for example, the student prepared a script or other plan to guide the development of their commercial. 4 points if they turned in a script, no points if there was no script. In the beginning, it's fairly common for students to forget to change the project name. And so I would sort of reinforce my expectations in that regard, that I want the project name changed specifically to, and I used it in quotes here, I wanted exactly ad agency. So that was worth 3 points. If they changed it, but it wasn't ad agency, they got only 1 point. And if they didn't change it and left it at untitled, then they got no points for that. All right. There might be times when I give bonus points. So for example, the program is intended to represent a commercial, all right, an animated commercial for some product. If I thought it was exceedingly creative or clever or technically complex in some way, I would give them an extra point. Okay, so again, I have a rubric that makes it easy to score my project. Now this one has 33 total points, but I would also create a Google Sheet that had the criteria along the top, and I could go in and put not only the scores, but notes as I'm grading that project. Now, another bit of scaffolding that I use is a presentation, all right? And I might go back and forth between demonstrating for the students how to write the project and the presentation that either explains what we just did or gives them a preview of what we're about to do. Okay, so if we just kind of look at a little bit of this presentation, we can see that we start out with a screenshot of what the finished game ought to look like, how, we need to have 4 sprites in this particular game. We need a way to design a tile. So it's the back of a tile, similar to what you'd see on the back of a playing card. I tend to put important notes in these red pop-ups, and I do use a lot of sort of animation and motion inside the presentation. So, sometimes these will pop up at various points as I'm talking about what I want them to do or what they should be seeing. So for this is an example of where I'm showing them sort of abstractly how objects put in one list are moved into another list. So they're actually seeing sort of an illustration of what's happening or what should be happening in the program. If I put all of the names of the objects that I have in the objects to be placed list twice, then I pick a random element, say it picked the number 3, that says that cake is going to be hidden under the first tile. So we put cake in the placed objects list. Now, right now it's in both lists, but then I want to remove it from the objects to be placed list so that it doesn't end up in that list, or it doesn't end up getting picked twice. Now, the next time I'm only going to have 7 items in my list. Okay, so my next random number is simply going to be 1 to 7, and now there's only 1 cake left to hide. Okay, so if I do it again, the next tile is going to have apple hidden underneath it. So I'm going to move apple and remove it from the first list. And I keep doing that until this list is empty. This list will then have 8 items in it, all randomly arranged. But anyway, this is a type of scaffolding that I would use to help them kind of see what we are doing in the program in some other form. Now, the last kind of scaffolding that I tend to use is where I might give them the entire set of instructions for writing a program. So let me zoom in a little bit, make this a little easier to see. All right, so you can see here, I've given them sort of a description of the game. This was an arcade game where you have a monkey at the bottom of the screen and you're moving the monkey back and forth, catching bananas. Every time you catch a banana, 2 bananas take its place at the top of the screen. If you miss a banana, it hits the ground. If you miss all of the bananas that are on the screen at any given time, the game is over. All right, you get points when you catch the bananas, and as you catch them, they speed up. All right, so this type of scaffolding walks them through picking the different pieces, setting the different properties. We use a lot of color coding. So if they see that it is in blue, it's a hint that that instruction is in the motion category. This one here that is sort of purple, that's a hint that they might look in the looks category for the instruction they need to perform that particular task. Okay, so just a very long outline that guides them through creating their project. And you could give them more or less detail, again, based on kind of where they are developmentally as a program. Those who are more capable or have been programming longer need less help. Those who are just beginning need more help and more detail. So again, this is another kind of scaffolding that I would use to support programmers as they are kind of learning how to be a programmer. Now, I will tell you that a project like this, the rubric for the Going Bananas project had 48 elements that were assessed. Essentially, I walked through the outline. I found every task or every instruction that I intended for them to add, and that became an element on the rubric. So it took a little while to grade this project. It had 48 elements on it. We did another one that was similar to this. It was called Freeway Frog, kind of a Frogger clone. And that one had 108 elements in it. That one, after I created the rubric, I sort of rethought myself and decided that next time I should have fewer elements because that one was very tedious to assess. But it actually was very detailed assessment. It gave them a very good view of how well they followed the instructions. And if they did everything correctly, they had a game that worked really well. Now for that one, even though it had 108 elements in it, I ended up dividing that score in half. I tried to shoot for about 50 points per full-blown project. I try to keep them relatively even and more points as we get more complicated. So the ad agency project was one we did early in the year. It was only worth 33 points. The Going Bananas and the Freeway Frog projects were later in the year. They were both worth about 50 points. Okay, so we have been increasing the complexity of the projects and the point values for the projects increase along with them. All right, so let's now talk about some of the common kinds of problems and how to deal with them. I know one of the challenges being a teacher trying to teach computer programming is that many of you, that's not what you were trained for. You were trained in math or science or social studies, but now you're being asked to teach some kind of technical skills. And so the programming aspect of it can be a challenge. So one of the things that I tend to do is to start with a reference project. So I'm going to go back to my teacher account for a second. I'm going to go to the My Stuff folder for my teacher account. Actually, I'm going to go back to my classes first. Well, hang on. I'm going to go back over here and navigate backwards. And then I can go to my classes. And then I'm going to go to my stuff. Okay. So I have another copy of FizzBuzz, which is called FizzBuzz Reference. Okay, and this is something I didn't share. The students didn't see this, but this is my own version of this project. So as I was developing the project or the task, I created the project to have this as the starting point. Okay, and then I disassembled it to create that challenge project that I then gave to the student. And I do that all the time. I'm always writing or rewriting a program. So the class I'm working with right now, the project that they're working on right now is called Conway's Game of Life. It's a mathematical simulation. And I wrote the project once to figure out how to make it work. And then I turned around and wrote it again. And the second time through, I created for myself a set of notes. Okay, and now as I'm going through class every day, this is my guide. This keeps me on track to make sure that I don't get overwhelmed and forget where we are or what we're supposed to be doing, because that happens. Even though I've been a programmer for a very long time, I can still confuse myself. So this helps to keep me kind of grounded, keep me going forward, make sure I know what I'm doing. I take a lot of screenshots of the code at different points. All right, so you can see here that we started with what's called the simplest implementation that could possibly work. We repeat 9 times. We pick a random number that is either 1 or 2. We add it to a list. Okay, that's very, very simple. But it's not representative of the fact that we're working in a grid that has rows and columns. Okay, so once we get the program to work, we do what's called refactoring. I use the definition, a behavior preserving transformation, to define refactoring. And that simply means that we're doing something in the code that will clean it up or improve it in some way, but that the user would not ever really notice. All right, the user experience stays the same. I'm changing the internal implementation to make it easier to understand. Okay, so you can see here, I have replaced that single repeat 9 with 2 repeat 3s, one inside the other. Now, this starts to communicate to someone who's looking at this program that this is intended to represent 3 rows where each row has 3 columns, or a 3 by 3 grid. And then for every column in a row, I put a random number that is either 1 or 2 into the list. We can then further refine that by replacing the literal values, 3s, with a constant named rows. And now it's much more expressive. I'm repeating rows times, and then for every row, I'm repeating columns times. And then for every column, I'm picking a random number that is either 1 or 2. But 1 and 2 don't say very much either. So in this simulation, what goes in a cell is a value that says that the organism at that location is either dead or alive. And so now instead of 1 and 2, we're using dead and alive. And so this is much clearer to someone who's reading this program than just having the 3 and the 3 and the 1 and the 2. Okay, but the point I was trying to make was simply that I create these notes for myself. So as I was going through, I'd already had the idea of how I wanted the program to work, but I started from scratch a second time. And I took the screenshots and was writing the instructions as I went. And again, I use this as my guide. So even though I've been a programmer for over 25 years, I still need these kinds of notes to help myself not get confused. Now, something else that you can do while the program is running, notice here, it says sprite 1 counter is 51. If I go to variables, I have a checkbox. I can change whether that variable stays on the stage by just checking or unchecking the checkbox. All right, so I might not want to see it. A lot of games, there's values I don't want the player to see. We did a guess the number game early in the year. I don't want the player to see what number the computer picked that the player is trying to guess. So I would turn that off from the stage. But while I'm working on the program or trying to figure out a problem, it can be helpful to put that back on the stage. Another thing that can be helpful, we have here this wait instruction. Okay, so at half a second, it actually runs pretty quickly. If I wanted to spend a little more time looking at the values, trying to figure out why is it not showing the buzz in the right place, or why was it buzz for 7 instead of 6? I can slow it down, and now it's easier to follow kind of what's going on. I can even slow it down farther if I needed more time. Okay, so now it waits 5 seconds before incrementing. Okay, so now I can actually look at what's going on and think about what's going on over here at the same time. I'm going to log out of this account for the moment, and I'm going to log back in to one of my other accounts so I can show you Conway's Game of Life, only because I've got some sort of debugging strategies in it that may be helpful. So I think we want to go to this account. All right, the first thing I'm going to do, Economy's Game of Life is very computing intensive. All right, Scratch has an internal speed limit ordinarily that limits the animation to 30 frames per second. That lets it look smooth. That's the same frame rate that we would see in an animated cartoon or a motion picture. But you can also turn off that limit and let the program run as fast as possible. And that's called turbo mode. Now, for this particular program, I want it to run in turbo mode because I'm doing 10,000 calculations every time I go through a loop. Okay, so I'm going to put it up in full screen. I'm going to click the green flag, and we can watch as the simulation runs. You can see down here as it's scrolling up, it's replacing these lists with new values, and every time it recalculates the list, it redraws it. All right, now I have this slider. A slider is simply another way to show a variable, and I'll go back in a minute to the inside, but I can drag the slider and control how long the program stays on any one state before it moves to the next. Okay, and then I can slide the slider up and slow it down a little bit. Okay, and that would let me analyze it a little bit farther. I've also implemented something in this program called debug mode. And the debug mode slider goes from 0 to 1. It's either off, which it is now, or it's on. And the way that debug mode works is that if I turn it on, when the program gets to the end of one generation in the simulation, it pauses. Now I can look to see if the lists are correct. I could look at a section of the grid to see if that has information that's meaningful to me. But then when I'm ready for it to continue, I simply push the space bar, and that will draw the next frame. Okay, but it's still in debug mode, so it makes me push the space bar again to move it forward. Okay, so now I'm in control of how fast this program is running. Okay, and the way that I've done those two things, if we look at the code, I've created a variable, which I named in all uppercase because I intend for that to be more or less constant. It's not really a part of the simulation itself. So we're setting debug mode to 0 at the beginning, and then we have an if between calculating the next generation and advancing to the next generation. If the debug mode has been set to 1, I simply wait until the space key is pressed. Okay, and then over here on my stage, if I right-click on any of these variables that I'm showing, I can switch between normal readout, which is just a way to represent what the value currently is, large readout, which gives me the value but without the name, and a slider. When I make it a slider, I can adjust its range. Okay, so I've set this slider to have a minimum range of 0, a maximum range of 1, and that's either off or on. Now, I've made this one a slider as well, but its range is set from 0.0 to 1.0. It is important in Scratch, if you want it to be a contiguous range of decimal values, that you use decimals for the endpoints, and that's true whether you have a slider range or random numbers. If you want it to be limited to just the whole numbers, the integers, then you can put the whole number values. So if I only wanted this to be, say, 0 to 10, I would put 0 and 10, and then it would only let me pick 0, 1, 2, 3, 4, 5, and so on. But I want it to be a decimal value between 0 and 1, so I have to give it the decimal values in the endpoints. The way that delay is used, down here at the bottom of my main forever loop, I have a wait delay seconds. And so it's going to pick up wherever the slider is and give me that as the delay. So if the slider is farther left, it will run faster. If the slider is farther right, it will run slower. All right, so that's another trick that you can use to try to debug a program, try to figure out what's going on. Another thing that I've done in debugging is make it a group effort. All right, I do a lot of this teaching and the programming that we do as a class where I'm guiding the students or demonstrating what I want them to do, I've got it on a big projector. So they see my screen as I'm teaching. And I can put up a student's screen. I can let them share their screen. And then I can see if other students are able to figure out what the problem might be. All right. So we help each other out in that way. We can make the bug hunting effort a class activity. And that's a good analytical skill for students to learn. Look at someone else's code and see if you can figure out why it's not working correctly. They learn so much more from that than if I simply tell them, oh, change this to this. Okay, because they'll just do it without really even thinking about why. But if you make someone else figure out what's wrong, then they have to go in and kind of analyze. So make troubleshooting a group effort. And then if all else fails, there's times even, again, with my 25 years experience as a computer programmer, I look at the student's code and in the moment, I can't figure out what's wrong with it. So I'll say, go ahead and put it in the studio. That'll let me see it. I'll take a look at it after class and I'll either send you an email or I'll tell you tomorrow what I found. And so I take the debugging activities offline. All right. And that way, again, sometimes I can look at code and right in the moment I can say, oh, I know exactly what's wrong with this. But sometimes I need quiet time that I can focus on it. And a lot of times it does just take a few minutes of quiet. Once I get a chance to sort of sit back, look at it without feeling the pressure of 30 eyes saying, ooh, what's the problem? What's the problem? I find that the problem is really easy to solve, but it's hard to do it in the moment. And so buying yourself a little bit of time. And that also sends the message to the student that that's sometimes what it takes, that sometimes you can't solve every problem on demand. And they should expect the same thing of themselves. Some things you have to sort of puzzle your way through. Sometimes you have to take a look at it and try to figure out kind of what's going on. So I do a lot of times take the troubleshooting offline. All right, so that brings us to the end of our agenda. I've talked to you about what Scratch is, kind of given you a general overview. I've told you about the teacher accounts and some of the ways that you can create your classes, add your students to them, use studios to collect projects from students, use starter projects that you can send out to the students and let them remix, how they would go about sharing and then adding their projects to the studio so that you can get visibility into those projects, either to help them with a problem or for grading. I showed you lots of different ways that I use to grade, a rubric that simply has a yes or no, it's either there or it's not, or a rubric that has different levels of conformance. The element that I'm looking for was there, it was almost there, it was there in a really great way, or it wasn't there at all. I've shown you some of the other scaffolding that I do using a presentation and sort of cycling back and forth between live coding and the presentation so that either I can show them what we're going to be doing so they have sort of a infrastructure that they can build on, or let's say that we did something and now I want to go back and kind of explain what's happening. All right, I can use the presentation either one of those two ways. I showed you the kinds of projects where I give them the complete guide or some level of a complete guide, either every single step with every single value, or maybe less specific and more general. Things like you need to make the sprite move 20 units to the right. All right, well, that requires them to know what does it mean? What specific instructions do I need to combine in order to get the sprite to move 20 units to the right? And what scaffolding or what support I would give to students, again, is going to vary depending on where they are developmentally as programmers. If they are less experienced, more scaffolding. If they're more experienced, we can do less scaffolding and more open-ended problems. So I hope that this has been beneficial to you. I have a couple of resources that I'm going to put into the chat. These are just links to some Scratch information about their teacher accounts and the resources that they make available, just so you'll have easy access to them. Again, I'm happy that you joined us for our webinar. Again, I hope you got something out of it. We will be recording, or we did record the webinar, and we'll be sending a link out to those who are registered. In the meantime, if you have any questions at all about Scratch or using it in your classroom, using the teacher accounts, anything that I talked about tonight, or any other issues that you may have run across that I didn't talk about, feel free to reach out. You can send email to info@Excalibur, EXCALIBUR -solutions.com. I'll put that in the chat as well. info@Excalibur-solutions.com. And we'll be happy to try to help you out. Well, thank you for joining us. I hope you have a wonderful evening or whatever time of day it is for you, and take care.